this is Sarah, and in this problem we will be learning how to graph rational functions. Here is our function. F of x equals x cubed minus 3x squared minus 4x over x squared minus 6x plus 8. Okay. So the first thing we want to do is find the asymptotes of this polynomial or rational function. So the first one we want to find is the horizontal asymptote. To find that, we have to compare the degrees of each of these polynomials. X cubed is bigger than x squared, and that's on the top. So if you have a bigger degree on top, that means you have no horizontal asymptote. So no horizontal asymptote, cross that out. So if we don't have a horizontal asymptote, it's very likely that we have a slant asymptote, because we have x cubed is 1 degree bigger than x squared. Here we go. To find slant asymptote, we have to use long division. As you can see here, I've already divided the top polynomial by the bottom polynomial. So x cubed is x squared times x is x cubed. Negative 6x times x is negative 6x squared. 8 times x is 8x, and when you add and subtract all these numbers, you get 3x squared minus 12x plus 0. Now you can divide that one more time. So x squared times 3 is 3x squared. Negative 6x times 3 is negative 18x, and 8 times 3 is 24. And we get a remainder of negative 30x plus 24. But we don't really need to know about that, because our main equation is x plus 3. As a result, that's our slant asymptote, and we will see that on our graph later. The next thing we want to find is our vertical asymptote. To find this, we have to factor both the top and the bottom. So as you see here, I factor out the x, so we get x squared minus 3x minus 4. And on the bottom, I factor this out, so it's x minus 4 times x minus 2. I've simplified that a little bit further, and I see that x minus 4 and x minus 4 both cancel out. And we are left with x times x plus 1 times over x minus 2. Sorry, that's supposed to be a negative. And to find our vertical asymptote, we set our denominator to 0. So x minus 2 equals 0. And when we simplify that, it's x equals 2. Now to find the limit notation, we write out as x approaches 2 from the right, hence this positive sign. F of x goes, and we'll find that out later. As x approaches 2 from the left, f of x approaches so and so. And we can see here that when we approach 2 from the right, the graph goes up. So we put an infinity sign. And as we approach 2 from left, we go down. So the graph is negative infinity. Okay, so going back to the x minus 4, we know that we have a hole because these two cancel out. So we set that equal to 0 as well, so x equals 4. And we plug 4 back into the simplified equation, which is x times x plus 1 over x minus 2. So we get 4 times 5 over 2 equals 20 over 2 equals 10. So our point would be 4 over 10, and that's our hole. Okay, the next thing we want to find is our domain. Remember, domain is DIVA, which is domain is vertical asymptotes and holes. We have one vertical asymptote and we have one hole. So x equals 2 and x equals 4. We write that in interval notation as negative infinity 2 in union with 2, 4, in union with 4, infinity. Okay, now that we have found our domain, we have to find our x-intercepts. So a shortcut to find our x-intercept is to set our numerator equal to 0. So hence x times x plus 1 equals 0. And we get x equals 0 and x equals negative 1. Our points would be 0, 0, and negative 1, 0. The last thing we have to find is our y-intercept. Now, our y-intercept is simply substituting all x's with 0. So 0 times 0 plus 1 over 0 minus 2. So we get 0 over negative 2, which would simply be 0. And our point would be 0, 0, or the origin. Now, last thing we want to do is graph. And as you can see here, I've already graphed our vertical asymptote and our slant asymptote. And I found our numbers for our other graphs, as you see here. So negative 2, negative 0.5, 1, negative 2 for the left side, or left of the vertical asymptote. And on the right side of the vertical asymptote, we have 3, 12, 5, 10, and 6, 10.5. As you can see here, I've changed the scale of our graph to 2s because when I graphed this originally, it didn't fit on the regular 10 by 10 graph. So if you just made that adjustment, it would look like this. Set our windows to that too. Okay, and that's how you graph a rational function. Thank you for watching, and please hope you enjoyed it.